You use LLM evaluation metrics all the time, but have you ever wondered what's actually happening under the hood? In the next few minutes, we're breaking LLM evaluation metrics down into ideas anyone can picture. No jargon, no assumptions. Let's get into it. Okay, imagine you are in a courtroom. There's a witness on the stand. The lawyer asks what happened that night. Now, a good witness says only what they personally saw. I saw the blue car stop at the signal. I saw the man in the red jacket cross the road. That is it. The moment that witness starts saying, well, I think maybe he was angry or probably he had been drinking, the other lawyer jumps up and says, objection, speculation. You cannot say that in court. You only speak about what you know for a fact. Now bring that same idea into our RAG system. In a RAG pipeline, your LLM gets a context document, some retrieved chunk of text, and its job is to answer the user's question based on that document. Faithfulness is the metric that checks whether every single claim in the LLM's answer is actually supported by that context document. Not guessed, not assumed, not hallucinated from training data, strictly supported. So if the document says the product was launched in 2021 and the LLM says it was launched in 2019, that is a faithfulness failure. The LLM made a claim the document never made. That is your witness speculating in court. Why does this matter so much? Because in real enterprise applications, legal, medical, finance, a hallucinated answer is not just wrong, it is dangerous. Faithfulness keeps your RAG system honest. It is basically your lie detector for the LLM output. High faithfulness score means your model is sticking to the facts. Low score means that it's going off script. And in production, off script is never okay. Okay, imagine this. Your bike starts making this weird rattling noise, so you take it to a mechanic. You ask him, Anna, why is my bike rattling? And he looks at you, smiles, and starts telling you about how the first two-wheeler was invented in 1885 by this German engineer, and how motorcycles evolved over 100 years, and how Tamil Nadu has one of the highest two-wheeler densities in the country. All of it is technically true. None of it answers your question. You're standing there thinking, bro, I just want to know what's wrong with my bike. That right there is a low answer relevancy score. Now flip it. The mechanic takes one look, says your chain guard is loose, tighten that bolt on the left side, 2 minutes job, done. That is high answer relevancy. He heard exactly what you asked, and he gave you exactly what you needed. No padding, no detour, straight to the point. This is what answer relevancy measures in LLM evaluation. When your user asks a question, does the model actually answer that specific question? Or does it drift off into related but unhelpful territory? A model can sound very confident, very detailed, very fluent, and still completely miss the point. That's the danger. In production systems, irrelevant answers frustrate users and destroy trust fast. So when we evaluate an LLM, answer relevancy checks how closely the response maps back to the original question. High score means the model stayed on topic. Low score means it wandered. Simple idea, but incredibly important to get right. Okay, let me give you a scenario. Imagine you walk into a library and you tell the assistant, Anna, I need to write a full report on solar energy. Please get me all the relevant books. Now suppose there are 5 books in that library that are perfect for your topic, but the assistant comes back with only 2 of them. What happens? Your report is going to be incomplete, right? You're missing information. You might miss key concepts, important data, whole sections of your topic. That is exactly the problem context recall is trying to measure. In a RAG pipeline, that is retrieval augmented generation, before the LLM even starts generating an answer, there is a retrieval step. The system goes and fetches relevant chunks of text from your documents or knowledge base. Context recall asks a simple but critical question. Out of all the chunks that were actually needed to answer this question correctly, how many did the system actually retrieve? If 5 chunks were needed and the system fetched all 5, your context recall is perfect, 1 out of 100%. But if it only fetched 3, your recall drops. And here is why this matters so much. Even if your LLM is brilliant, even if it reasons perfectly, if it is working with incomplete information, the answer it gives you is going to be incomplete or wrong. Garbage in, garbage out, duh. So context recall is your early warning system. It tells you, hey, your retrieval step is leaving information on the table. Fix that first before you even worry about what the LLM is doing with it. Okay, let me ask you something. You remember college assignment days, right? You're sitting in your room at 2 a.m., you've done the research, you know your stuff, every fact is correct, but you just dump paragraph after paragraph. First you talk about the conclusion, then you jump back to the introduction, then you go sideways into some random point. Your professor reads it and says, "Dah! The content is fine, but this reads like a rough draft." Marks come down. Sound familiar? That is exactly what coherence and fluency is about when we talk about LLM evaluation. See, an LLM can technically give you all the right information. But if the response jumps randomly from one idea to another with no connection, or if the sentences feel clunky and unnatural, it fails the reader. Coherence means the response flows logically. One sentence leads naturally into the next. Ideas build on each other. Nothing feels like it came out of nowhere. Fluency means the language itself reads smoothly. No broken grammar, no awkward phrasing, no jarring stops. Together they answer one simple question: does this response actually read well? Now, why does this matter for you as someone building or evaluating AI systems? Because users don't read evaluation reports, they just use the product. If your model gives technically correct but choppy, disconnected answers, users will feel something is off, even if they can't name it. They'll lose trust. So, when you're scoring an LLM's output, don't just check if it's factually right. Ask yourself, would I be comfortable reading this out loud? If the answer is no, coherence or fluency is the problem. Okay, let me start with a scenario you might actually face. Imagine your team lead tells you, "Hey, send the client a status update. Keep it to exactly 3 bullet points, nothing more." Simple enough, right? But you get a little excited. You write a beautifully detailed 5-paragraph essay covering everything. The content is accurate, the client would probably learn a lot from it. But your team lead is now stressed because the client asked for something short and you sent a wall of text. You followed the spirit, but not the instruction. That is a real problem in professional life, and it turns out it is a real problem for LLMs too. That is exactly what instruction following measures. When you give an LLM a prompt that says, "Respond in JSON format, use only 4 bullet points, keep the answer under 50 words. Instruction following is the score that tells you how strictly the model actually obeyed those rules. Not whether the answer was smart or accurate. That is a different metric. Just, did it do what you told it to do, exactly how you told it? Now, why does this matter for you as someone building with AI? Because in real products, format is not optional. If your backend expects a JSON response and the LLM sends back a friendly paragraph instead, your code breaks. If a customer-facing chatbot is supposed to give a 3-step answer and it writes an essay, the user experience suffers. Instruction following is the discipline that makes LLM output actually usable in production. Think of it as the professionalism check, not just what the model knows, but whether it can follow a brief properly. And that's it. You now understand the core ideas, not just the buzzwords. If this clicked for you, follow Hired by Basics for more explainers like this one. See you in the next video.